So let's look again at what happens when we use electrons. Here's the slit. Here are the electron beam, but they spread out to a point where there's a minimum, a maximum and a minimum, and the angle is theta. And we have said that the wavelength lambda equals d, which is the width of the slit here, sine theta. Now, since lambda doesn't change, it means that if you make d smaller, then the angle theta will increase. So as that slit gets smaller, this angle will get larger. The wave will spread out more. D is, in a sense, the measure in the y direction of the position of the electron. You know that it must be somewhere between those 2 points, because otherwise it wouldn't get through the gap. So D is delta x. It is the uncertainty in the y position of the electron. What about the momentum? Well, the momentum of the wave, which is coming along here, has a component part here, delta p. It is the uncertainty in the momentum in the y direction. And delta p is simply p sine theta. But we know and have just shown that p equals h over lambda. Or you could write that as lambda equals h over p. And so using this formula here, lambda, which is h over p, equals d sine theta, which means h equals dp sine theta. But what is d? Well, d is delta x. What is p sine theta? P sine theta is delta p. And so you get not quite what I started off with, because there are some inaccuracies in this approach, but you get the broad principle that the uncertainty in position of the electron as it goes through this slit, that's the uncertainty of position in the y direction. It's got to be somewhere in the slit, otherwise it won't go through the gap. But the uncertainty in the y direction of the position multiplied by the uncertainty of the y direction of the momentum is h. And that's an illustration of the Heisenberg uncertainty principle. The essential point to notice is this is not an instrument issue. The uncertainty is not because we cannot measure things properly. It's a fundamental inability to measure the two aspects of position and momentum at the same time.